Hello and welcome back. I'm really excited to talk about bitwise operators in this new section. Now, the bitwise operators are useful for operating on bits. Bits are suitable for keeping Boolean information. Now, the Boolean information means a 0 or a 1, 0 in order to represent false and 1 in order to represent a true value. Now, the traditional approach is to use an integer in order to store true, that means 1, and 0, that means false. But that's a huge amount of wastage of memory because a single bit is sufficient enough to store a 1 or a 0. So in system programming in particular, it is a regular practice to keep Boolean information in set of bits. Using integer for keeping Boolean can definitely result into wastage of memories because a single integer storing a single 1 is actually using 32 bits, whereas as I told you, a single bit is sufficient enough to store a 1 or a 0. And that also is going to slow down the performance of program because while comparing an integer with other, we'll actually compare 32 bits with other 32 bits. Let's take an example to understand the usefulness of bits for storing Boolean values. Say there are 8 students in a class and the teacher took an exam and some of them are passed in the exam and some of them failed. And the teacher used this array in order to keep the information in the memory for the processing purpose. So the teacher declared 8 elements integer array, and if the student is passed, it is initialized, the element is initialized with 1, and if the student failed, then it is initialized with 0. So actually what the teacher is doing is using this 8 elements array where each element is of 4 bytes, right? Each integer is of 4 bytes, and each 4 byte is used to keep a 1 or a 0. The total size of this array is actually 4 times 8, that is 32 bytes. That means 32 times 8, each byte is of 8 bits, that's 256. 256 bits are used for keeping 8 Boolean information, where 8 bits are just sufficient. So there is a huge amount of memory that is used for keeping the Boolean values there. Instead of this, if the teacher had declared a character variable, and we know that any character variable takes 8 bits, and initialize that character variable with this value, then in 8 bits, he could have stored all this Boolean information. So here the difference is that this is 1 bit instead of 4 bytes, that is 32 bits. This is 1 bit only. So 1 bit is sufficient enough to keep a 1 or a 0. So this character variable r is just sufficient for keeping all these Boolean values. But the question is that how you are going to access individual bits. Here in case of array, if you want to refer a particular element, you can just use the subscription operator, right? And that actually going to refer the first element, this all 32 bits. But individual bits, accessing individual bits is only possible by using bitwise operator. And here is the usefulness of bitwise operator. You can use the bitwise operators for accessing individual bits, for manipulating these bits, for comparing individual bits with some other bit. So here is the helpfulness of the bitwise operators. So they will help us to operate on bits of a variable. And if we are using a variable for keeping the Boolean information of or set of Boolean information, then we can use the bitwise operator for initializing each bit of that variable and manipulate them as well. So these are the bitwise operators available in C. I'll just introduce these bitwise operators in this slide, but I'll explain each of them in the later lectures. Don't worry about the details. I'll definitely give you all the details of each of these bitwise operators with programs. So this is called the bitwise left shift operator. The purpose of this left shift is to shift each and every bit of a value towards its left. And this is bitwise right shift. This actually shifts every bit towards its right. And this is bitwise AND operator. Unlike the logical AND, it is having a single ampersand there. And this is called the bitwise OR operator. And again, you can see that it is a single pipe sign there instead of 2 pipes that we use in case of logical OR operation. And this is the bitwise XOR operation. And this is called the bitwise complement operation. Among all of these, this bitwise complement operation is actually unary in nature. And all the others are binary in nature. All of them are binary in nature. That means they will operate on 2 operands. Now I'll give you details of each of them, as I said, with some programs as well. Obviously you'll see them in action, so don't worry about the details of these things. They will be clear to you with the next lectures. Thank you very much for watching.